Hello guys, in this video we are going to discuss the solution of the problem sort a k-sorted doubly linked list. So let us look at the problem statement. Problem statement says given a doubly linked list, each node is at most k indices away from its target position. The problem is to sort the given doubly linked list. The distance can be assumed in either of the direction, left and right. For instance, if this is the doubly linked list which is given to us and the value of k is equals to 2, then after sorting this doubly linked list, the doubly linked list looks something like this. And the head of this doubly linked list is what we need to return. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say this is the doubly linked list which is given to us and the value of k is equals to solve this problem. What we are going to do is we are going to use priority. So let us see how by using priority key be able to solve this problem. So what we are going to do is we are going to push k plus 1 elements on this priority queue. So let us do that. And this priority queue is something we are going to maintain it in the form of min heap. So let us do that. So 3 is the first node. So we are going to push 3 onto the priority queue. Then comes the second node, which is 2. So after pushing 2 onto the priority queue will look something like this. And then the next element is 1. And after pushing 1 onto the priority queue will look something like this. Once we have pushed k plus 1 elements on the priority queue, then what we are going to do is we are going to pop an element from the priority queue. So let us do that. Let's pop an element from the priority queue. So our answer will look something like this. The first element which got popped is 1 and that will be over here. And after popping an element from the priority queue will look something like this. And after popping, let us push another element onto the priority. So remember folks, we have already pushed elements till this position. So the next element to be pushed onto the priority queue is 5. So we are going to push 5 on the priority queue. And then we are going to repeat the same process, which is we are going to pop an element from the priority queue and we are going to push an element onto the priority queue. So let us do that. So let us pop an element from the priority queue. So this element will be popped and let us push an element onto the priority queue. So the next element is 6 and this is what we are going to push. And after the push operation, the priority queue will look something like this. Again, let's pop an element from the priority queue. So 3 got popped and 3 will be over here. And then let's push an element onto the priority queue. So now the next element is 4 and let us push it onto the priority queue. After pushing 4 onto the priority queue, the queue will look something like this. And then let's pop an element from the priority. Then the priority queue becomes something like this. Now at this position, there isn't any element to be pushed onto the priority queue. So we are not going to push any element onto the priority. And then we are just going to perform the pop operation. So 5 will be popped and it will come over here. Then the priority queue will look something like this. And then eventually 6 will be popped and it will come over here. And in this way, if you see, we have sorted the doubly linked list. So that's the general idea behind solving this problem, folks. Now let us see how we can manipulate this in doubly linked list itself. So for that, let us take the same example again and let us repeat the same process. So the idea is to push the first k plus 1 element onto the priority queue. So let us push it. So after pushing the first k element onto the priority queue, the queue will look something like this. So in order to sort the doubly linked list, what we are going to do is rather than moving the nodes of the linked list, we are going to change the content of the nodes. So what do I mean by this is we don't really have to manipulate the next or previous pointer. We just have to swap the content or we just have to change the content of the node. Let us work with an example to understand it better. So over here, the first node which we want to pop is 1. For this, what we are going to do is we are going to take a pointer and we are going to set it to the beginning of the linked list, which is this node, and then we are going to pop an element from the heap. So the first element got popped. Now this one got popped and we know that the correct position of this one is at this place. So what we are going to do is we are going to change the data of PTR to 1. So simply this data will be overwritten by 1. And as you can see, next and previous pointer remains as it is. And then let's push another element onto the priority queue. So the next element is 5. So let us push 5 onto the priority queue. After pushing 5, the priority queue looks something like this, and the doubly linked list looks something like this. And folks, as you can see, the content of this node has been changed to 1. After changing the content of the node, we are going to move PTR to the next element. So the PTR is at this position. Let us repeat the same process again. 2 will be popped and the content of PTR will be changed to 2. Since in this case it is 2, so then 2 remains 2 itself. After that, we are going to push an element onto the priority queue. So the next element to be pushed on the priority queue is this, and after push operation the priority queue will look something like this and the doubly linked list will look something like this, and our PTR is at this position. Now let us repeat the same process. So we are going to pop 3 from the priority queue and we are going to update 3 over here, and then we are going to push the next element onto the priority queue. So the next element is 4 and let us push 4 onto the priority queue. After pushing 4, the priority queue looks something like this and the doubly linked list looks something like this, and our PTR is at this position, and let us repeat the same process. So 4 will be popped and 4 will be put at this position. So this becomes equals to 4. And since there isn't any element to be pushed onto the priority queue, so the priority queue will look something like this and the doubly linked list will look something like this, and PTR is at this position. So let us again pop an element from the priority queue. It will be put at PTR position, after which the priority queue looks something like this and the doubly linked list looks something like this, and PTR is at this position. Now all we have to do is pop the final element and update this 4 to 6. And in this way, if you see, we have sorted the doubly linked list by just changing the content of the nodes of the doubly linked list rather than changing its next or previous pointer. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. Let us say we want to sort a k-sorted doubly linked list. For this, the first thing we are going to do is we are going to check if this is a empty linked list, in which case we just have to return head. Otherwise, let us take a priority queue PQ. Let's take a pointer new head, which is just to preserve the head pointer. And the first thing which we are doing, as we have discussed, is we are pushing first k plus 1 elements onto the priority queue. So let us do that. While I is less than k plus 1 and head q dot heap push, we want to push a node onto the linked list. So PQ, and what do we want to push over here is head of data. So we have pushed an element onto the priority queue, and then let us update our head. So head equals to head dot next and I equals to I plus 1. In this way, using this while loop, we have pushed first k plus 1 elements onto the priority queue. Now the next thing which we want to do is we want to pop an element from the priority queue and update the nodes of the doubly linked list. So for that, let us take PTR equals to, and then let us iterate onto the priority queue while priority queue is not empty. And over here, let us pop an element from the priority queue. So for that, data is equals to heap queue dot heap pop, and then PTR data is equals to data. In this way, we have overwritten the content of a particular node. After overwriting the content of the node, let us update our PTR to the next node. So PTR is equals to PTR dot next, and let us push an element onto the priority queue. So for that, if head exists, then in such case heap queue dot heap push onto the priority queue, we just want to push head dot data, and after that let us update our head. So head equals to head dot next, and towards the end all we have to do is we just have to return. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. So over here, the first thing which we are doing is we are checking whether it's an empty linked list. If it is an empty linked list, then we are returning head of the linked list. Otherwise, a priority queue is taken. Head of the linked list is preserved, I equals to 0, and then we are pushing first k plus 1 elements onto the priority queue. After that, we are iterating on the priority queue while priority queue is not empty. And then we are popping an element from the priority queue. We are updating the data of node, and then we are pushing an element onto the priority. And towards the end, we are returning it. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the concept of C++ implementation remains the same, folks, but the implementation is slightly different. So let us see what do I mean by this. So the first thing which we are doing is we are checking whether it's an empty linked list. If it is an empty linked list, then we are returning null. Otherwise, we are taking a priority queue. Within this priority queue, first we are pushing the first k plus 1 element onto the priority queue, and then we are iterating on priority queue while priority queue is not empty. The first thing, and this is the difference, folks, over here, rather than changing the content of the node, we are manipulating the pointers. So let us see how we can do that. So the first thing which we are checking over here is we are checking whether the head is null or not. If new head is equals to null, then that simply means this is the first element, because of which last is equals to pq.top. The first element is the last element as well as the head of the linked list, and then we are manipulating the previous and next pointer to point to null. So essentially what we are doing it over here is last equals to new head is equals to first element of priority queue, and then the next and previous pointer of this first node is equals to null. And if this is not the first element of the newly linked list, then in such case last next is equals to the top element of priority queue, and then the previous of priority queue should point to the last element, and then eventually last we are updating to pq.top, and then we are popping an element from the priority queue, and then as usual we are pushing an element onto the priority queue. Towards the end, last next should be null, so that is what we are doing it over here, and we are returning new head. That's the C++ implementation, folks. Now let us submit our solution. Our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.